How to build secure and deploy a real-time scalable chat messaging web app using Node.js, React and Firebase for hosting along with Firebase Realtime database. This project was inspired by a Fireship tutorial, a public group chat web app with React and Firestore instead of the real-time database. The application used Cloud Functions and a NPM library called bad words to filter each message. If a bad word is detected in the message, the user will be banned from the public chat. This is enforced by the database security rules. We are going to recreate this project but using the real-time database. We will also extend this project to a private chat messenger application and a user's search function. Along with setting stronger security rules with data validation and indexing, the chat messenger will be built with a traditional two-part system, a latest message list, and the chat partners list. New message and messages viewed indicators for visual confirmation allows for better user experiences. We will extend the blocking system to allow users to block other users inside the private messenger feature. This will be enforced by the security rules inside the real-time database after initialized by the user. We will also have to extend the server-side logic in Cloud Functions to handle user-to-user blocking and push notifications. To get started, create an empty folder and open it up in VSC. Open the terminal and enter npx create react app and period. This will create a React project inside the folder you have opened in VSC. Next, install Firebase and React Firebase hooks. After installing the first modules, let's run npm start so we can view React's boilerplate code and confirm installation was successful. We won't be going over the CSS for this project to save time, but the source code for the entire project is available in the description below. Copy and paste the CSS code for the project and paste it inside of app.css. Next, we want to add the Font Awesome CDN in our index header. We can install Font Awesome by npm, but the CDN works for this tutorial. Copy and paste the CDN link inside the index.html header. Create a file inside of the source folder and call it firebase.js. This will hold our Firebase project config. Go to firebase.com and create a project. Enter the name of your Firebase project. Inside your project dashboard/project settings, you will need to register an app. Click on web icon and name the app to be registered. Firebase will generate configuration data associated with your project. Copy your config. Inside firebase.js we need to import Firebase modules. We will import Firebase compat app and get database from Firebase database. Then we need to initialize our app's API to Firebase by using the project config. Create a const that equals get database and pass the initialized app as the parameter. This will be the reference to the root of our real-time database. Then export Firebase and our get database variable. Inside app.js we will import React and useState. Import our variables from firebase.js. Import Firebase compat auth and useState auth from React Firebase hook/auth. Finally, create a const called auth equal to firebase.auth. In app function create const user equal to use auth state and pass our auth const as the parameter. In the return we will set a div and the class name as app. Then we will create a ternary operator stating if user, check user, else, sign in. Let's create our sign in function. Set the return with a section HTML tag. Create our check users function and set the return as empty for now. Inside the sign in function, create a const sign in with Google equal to a function. Create a const provider equals to a new Firebase auth sign in with Google. Use auth.signin with pop-up and pass in our provider as a parameter. Then in return add a button with an onClick listener and pass our sign in with Google function. Import setRef and onValue from Firebase database. Inside check users function, use onValue, ref, our get database variable reference from firebase.js, and a query to a user's directory, / the user's UID. Set parameter for the database's data snapshot return. Then we will check if the data snapshot is empty. If the data snapshot returns empty we will use the set method. Use same query as onValue and create the payload for the user. Go to Firebase project and view authentication. Enable authentication for Google. Next, create our real-time database and set security rules to test mode for now. Press sign up in the app and now the payload has been set inside the database. Create a new function called main action. Set the return of check user to call the main action function. Inside main action return, add a header and section with HTML. Inside the header add a function called sign out. Now create sign out function. Set sign out function to return auth.current user, and inside the return, add a button that will call firebase.auth sign out in an onClick event. Add a function in the section tag of main action, called public chat. Now create the function called public chat, under the main action function. In the return add two HTML elements, a main, and a form. Notice the class names for each element. Add useRef and useEffect in React import. Then limit to last in Firebase database import. Create a const in public chat function called dummy equal to useRef. Create another const array equals to useState and set empty array as parameter. Create a useEffect function. Inside, call on value, to the public chat directory, and limit to last 25. Set the promise variable. On every call to this on value we need to set public chat useState to an empty array. Check if promise data is null. Call object as an object constructor. Then .values. This returns an array of values of the enumerable properties of an object. Pass in the data snapshot as the parameter. Each message in the database is an object and its values we need to return. Map the returned array. This calls a defined callback function on each element of an array, and returns an array that contains the results. In the callback function we will set the public chat's useState with the maps callback return. Now that we have set our public chat's useState, add a call to our useState inside of the return main element. We need to map the array and pass it to a new function called chatMessage. We can pass the map data as a parameter to chatMessage. Underneath our public chat's useState value mapper, we can add a span that sets the useRef value. This will make sense later. Create the chatMessage function with the props parameter. Create a const which will be an object equals to the props.data. Inside the object we will set the variables of which will be the values of each public chat object. With each UID we check if it is equals to our current user. We will make this a const and the value equals to a class name defined in our app.css. Now set the return. This will generate a child element inside of our HTML main tag of every public chat message. This will consist of the sender's name, image, and text. Now we need to be able to create a message. Go to the form inside public chat. Add an input inside of the form. Then at the top of public chat add another useState. Set as empty string on start. Set input value to the form value useState. Add on change listener. Call a function to set form value useState as the input's value. Now set a button with type of submit. In the form add an onSubmit event handler that calls a function. This function will be called sendMessage. Above the return create a const called sendMessage equal to asynchronous function. Use e for event as the parameter. In the function set e.prevent default to prevent this function from executing on start, meaning when the public chat component is mounted. Create a const of an object equals to the current user. We are going to add push to our Firebase database import. Reason is we want the unique key for every public chat message that is sent as the database location and embed this in the message object. Create a const called message key and use pushRef and the initial public chat directory. This is our unique key. Use await and set to create the payload. Use message_key as the message ID and the payload destination. Set the form value to an empty string at the end and make sure the set target is the message_key. If we test out the application now, we can see that the public chat is working correctly. We do now have one problem, and that is the chat list does not automatically scroll to the last message. To fix this, we need to go back to our public chat function. We will now utilize the useRef we have set and placed in our span tag. Create a const that equals a function. Inside we will call dummy.current and scroll into view. Set the behavior to smooth. Now we can create a useEffect that calls the function. Set the public chat's useState in useEffects array. We are now going to add cloud functions to our project. To do this you need to upgrade your project to the Blaze plan in Firebase. To set up billing for Firebase you need to go to Google Cloud Platform. Install the tools needed to connect Firebase CLI to your project. Then run command Firebase login. Log in with the account registered for your Firebase project. Now run command Firebase init. Select real-time database and functions. Select existing project. Then click the project you created inside of Firebase. Allow the installation of dependencies inside of Cloud Functions. A folder called Functions will appear at the top of your project. View index.js inside Functions folder. Remove all but the functions import and import admin from Firebase admin. With admin initialize app with functions.config.firebase. cd into Functions folder via the terminal and run command npm install bad words. Create a const called filter equal to bad words import. To start our function, we will export and the name of the function. It will be equal to functions.database.ref, and point it to a specific directory. With onCreate we can have this function activate on every new message sent to the public chat. This returns a promise, and so we will name it snap. Create a new filter object and initialize the snap variables in the public chat message payload. With an if statement we can filter the text and check if it contains bad words. If so, we create a variable that cleans the text. Create the new text value. Then update the message with the initial message ID as the query and child of text. Then we can add this user to a public block list by using the UID of the user. From the time I created this project and duplicated it for this tutorial, to deploy Cloud Functions we will need to enable Artifact Registry API inside of the Google Cloud Platform for the project you deploy for. Deploy functions with Firebase deploy only functions. Now that our Cloud Function is deployed, we can now test it by sending a bad word. The server catches the bad word, updates the message, and blocks the user. Problem is, we can still send messages to the public chat. Reason why is, our security rules are not put in place to enforce the block. So let's create our security rules by going to Real-Time Database Rules. Right now we are allowing the reads and writes to any and every possible directory. To fix this we need to add the users and public chat directory and only allow reads and writes to them. Inside each directory we can add conditionals for validation and authorization. Add a users directory and then allow reads if request is authenticated using auth.uid. When we write to the users directory we write inside of a subdirectory by a UID that belongs to the current user. So only the user with that UID should be allowed to write to this subdirectory. So allow writes if request is authenticated and the UID matches the subdirectory. We should always validate the incoming data to check if they match the data type we have designed for. Add another directory called public chat. Allow reads if request is authenticated. For writes we will check if request is authenticated, and then have our security rules look inside the public block directory, and check if the requesting user's UID exists inside of this directory. We will also validate the data on each write request, to make sure they're of the same data type. Publish the security rules and you can see the blocked user is no longer able to send messages to the public chat. The block is being enforced by the security rules. If we add the same rules for reads as we do writes, then the blocked user will not even be able to view the public chat. This finishes the Fireship tutorial and it's time to extend this to a private messenger. Before we start building the private messenger, let's talk about the application flow. First off, in regards to this global use states block. This is a node package module called useBetween. I stumbled upon this module while trying to simplify handling use states between multiple components, and create a headache-free manageable UI flow. Let's look at how the app works. On app start, we have the auth use state hook. If user equals to not authenticated, it returns sign in. Else, it will return the main action. This is where we will utilize useBetween module. Inside main action we will have three main use states that controls the UI flow. Action type, chat user, and block user. On default action type is set to 1, chat user is set as an empty string, block user equals false. Anytime these use states are modified, the main action will change its return corresponding to the condition specified in the return. Inside get user and latest messenger, clicking a child component will set the chat user's use state, and then setting the main action's return as the private messenger. Inside the private messenger we will have another condition deciding UI flow. This checks if the user wishes to block the current chat user. Block user equals false, then private messenger, else, block user. Pressing back inside private messenger returns all useBetween use states back to default. Which means main action returns latest messenger. Now that we can visualize how the application is going to work, let's go ahead and get started. First install useBetween with npm useBetween. Then add the import at the top. Above app function, create a const called shared access that equals a function. Set action event use state and set it to 1 by default. In the return, add the use state variables. This will give us access to this use state in any component. Inside of main action function, at the top, add a const that is equal to useBetween, and pass our shared access function as the parameter. Inside the brackets, we can add the part of the use state we will need inside this component. That is the action event value. Inside of the header tag, replace sign out with header default. Then under main action function create the header default function. Inside create a const equal to useBetween. This time we will use set action event from our shared access. In the return add 3 buttons with the onClick event set to call the set action event and pass the correct number. With our action event value in our main action function, we are going to add a multiple ternary operator. This conditional will follow as such. If action event equals 1, then go to latest messages. Else if action event equals 2, then go to public chat, else go to get users. Then we will need to create these extra functions. Above public chat add a function called latest messages. Inside add a return, with a main HTML tag, and a paragraph tag, that states this is the latest messages. Then create the get users function. Inside add a return, with a main tag, and a form tag. In the main add a paragraph tag that states this is the get users component. Make sure you capitalize the shared access function. Now if we click the header buttons the UI updates with the UI flow. Let's create search users. Inside get users add two use states set to an empty array. Data set and query. In the form add an input with an onChange event that calls a function. Above the return create the handle change function with event as parameter. Set a const that equals event target value. Above the function create a use effect. Inside use on value to the user's directory. Check if the data snapshot is null, then set query use state to the data snapshot. Back inside handle change function, set dataset to empty array on every call. Then check if the text and query use state is empty. If not, take the object values of the query use state and map them. Check if each data map.name starts with the text value. If so, we set the data set use state with the return. In the messenger return main tag, we can map our data set use state and pass it to a new function called selected users. Create the selected users function with the parameter of props. Create the const of an object equal to the props message. In the return we will add the HTML to show the corresponding user. Make sure to use the correct variable name in set data set use state. If we run our app, you can see the search query is working. Now under latest messages let's create a function called messenger. Have it return a main tag and a form tag. Then at the top inside our shared access function we will add three new use states. Chat name, chat image, and chat user. They will be set to an empty string by default. Then return the new use state variables. Now under header default function, create a new function called header private messenger. We will create a const equal to use between and set chat name value, chat image value, set chat user and set action state from shared access. In the return add two button groups. The first one will contain the chat name and image. The second one will have a go back button. Inside the go back button we will have an onClick event that sets the chat user use state as empty and the action event as 1. Inside the selected users function return, we will add an onClick event that sets the props message name image and UID to the correct use states, which we need to add up top with use between. Inside of main action function we need to add the chat user use state in our use between object. Inside the header we will add a ternary operator. If chat user is null, go to default header, else, header private messenger. In our section we will update our ternary operator to include the chat user use state. If action event equals 1 and chat user equals null, go to latest messages, else if action event equals 2 and chat user equals null, go to public chat, else if action event equals 3 and chat user equals null, go to get users, else, go to messenger. Now if we run our app and search for a user. If we click on the user, we are in the messenger part of the application, and with the private messenger header working. Inside messenger function. Add private chats use state set to empty array. Set a const for use ref hook. Next, create a use effect with an on value call inside. Set query to private messages / current user / chat user with limit to 25. At the top, set chat user, chat image, and chat name from our use between shared access function. Inside the on value call, set private chats use state to an empty array. Check if the data snapshot is null. If not, map the data and then set the private chats use state with the return. Inside our main tag, set private chats use state mapper and pass it to our new function. Add the span tag use ref underneath. Then create a new function called private message with a parameter. Create a const with our param.data values. Check if the UID equals current user. This sets the class name of the child element that we set inside the return. Inside the form tag, create an input with value set to form value, and an onChange event that sets the form value. Under the input add a button with type of submit. At the top add the form value use state with empty string. Inside the form, add an onSubmit event that calls send message. Then above return we will create a const, send message equals to asynchronous function. Set prevent default. Add our auth current users object. Now set the individual unique key variables for the users and chat users private message payload. Create a legible timestamp for the messages. For the payloads we need to create 4 set methods with await. Set the form value to empty string at the end of send message. Then inside each set method, we will add their respective values. Before we can send a private message, we will have to update the security rules to allow reads and writes to the new directories. Under Users, add latest message and then the UID subdirectory. Inside, allow read if the UID directory equals requesting user's UID. Allow same condition for writes and add or and the user-to-user block condition. We will explain this when we get to blocking. Next we will validate the data that is meant to be inside the latest message payload. Next we will create the private messages directory. We will copy all that is inside latest messages. Then our last two validation rules, we need to replace them to match our private messages payload. Now if publish the rules and check in our app, we can send private messages. The latest message is a directory that holds only one message at a time, and that's the last message. The private messages contain the list of messages between users. Go to latest messages function. Create latest chats use state with empty array. Set a use effect and call on value to latest message directory. Set latest chats use state to empty array and check if the data is null. If not, map the data and set latest chats use state with the return. Inside the main tag, set our class name and add our latest chats mapper and pass the return to a new function. Create the latest messenger function and set the parameter. Grab our set chat user hooks from use between shared access function, then set the params data for the message values. Create a if else statement. If viewed and sender equals current user UID. Else if not viewed and sender not equal current user's UID. Else, set the default message element. Logic is simply, if viewed, show message viewed element, else if not viewed, show new message, else show default message. If we check our application, we can see the latest message is showing and the new message indicator is blinking. But right now if we click on it to go to private messenger, we are not updating the latest message stating we have viewed the message. To fix this, go to the messenger function and create another use effect under the first. Inside, call on value to the latest message directory under users UID and chat users UID. Check if the data is null and set another if statement checking if the last message was viewed and if we did not send it. If not, we will update the latest messages for both the user and chat user. We will need to add the update import for Firebase database to use the update call. If we test our application again, we can now see the new message, and message viewed is working and our private messenger is built. Before we move on, let's add our auto scroll to the messenger function. Under the use effect, create the scroll to bottom function. Add another use effect that calls the scroll to bottom function and set private chats use state as the dependency array. To set up blocking, first set block user use state inside shared access function. Then create a new header function, header block user, and create another function called block user. Inside main action, add block user use state from use between and in the header tag, ternary operator. Conditional equals, if chat user null and not block user, go to header default, if chat user and not block user, got to private header, else go to blocked header. Inside section tag, after get users set logic as if block user, got to block user, else go to messenger. Inside header private message second button group, add another element that calls block user function with on-click event. Underneath, add set block user use state inside on-click event with set to false as param. Add block user use state hooked to the use between shared access function. Then add the block user function. Inside header block user function, add chat name, chat image, set block user use state hooks from shared access function. Now set the return with the header layout, adding the go back button that calls set block user to false. Now then, inside block user function, set the use between use stat hooks. Inside the return, we will have a button with an on-click event. Create the handle block function. Set a unique key for the block request. Use set method with the unique key as location target, and set the payload. Finally, set action event to 1, set chat user to null, and set block user to false. In our security rules at the bottom, add server block and allow writes if auth is not null. Reads will equal false, then lastly add validation for the data values. Publish the new rule changes. If we check out our application now and enter the private chat messenger, we can see the block button. Clicking it displays the block user component, and our block user feature is working on the client side. Now let's add server-side code that will handle the blocking request. Inside functions index.js. Export another onCreate function called private block. Set the values of the database block object. Create and set method with admin.database with ref of the block directory /senders UID /offenders UID. Inside the payload, add the offenders UID as the value. Now we will add remove methods that will erase the senders and offenders latest messages and private messages between each other. Finally, remove the trigger object from the database. Now deploy our server-side code to Firebase with Firebase deploy only functions. If we run the application and block the chat user, we can see the server blocked the user and deletes all messages between the two users. Now if this user tries to message the person that blocked them, the message will fail because our security rules is enforcing the block. This line of code in our security rules works as such. When you send a write request to another user, it will check inside the block directory and the subdirectory that belongs to the user you are attempting to message. Then it will check if your UID is listed as a blocked user. If so, your write request will be denied. We are now going to add push notifications for private messages. Inside your project settings / cloud messaging, we are going to enable the legacy version of the cloud messaging API. Enable cloud messaging inside Google Cloud Platform. Now inside our app.js, at the top import Firebase compat messaging. Then go to the main action function. Using notification.request permission, we'll add a pop-up in the browser. If user accepts with then we call Firebase messaging get token. This will return the token initialized for this device, and finally, we can update the user's token value with the Firebase update method. Go to the messenger function, and at the bottom of the send message async call, we need to add a set method. This will be used to tell the server to send a push notification to the user we messaged. First we need to update our security rules to add this new directory. Inside add server message and allow writes if auth not equal null. Reads will be set to false and then validate the values of the request. If we run the application we can see the pop-up ask to allow notifications, but when we accept, the user's token value is not being updated. The reason for this is, Firebase messaging is looking for a specific file in your project that is not there. For Firebase messaging to work we need a service worker to initialize with our project credentials. Inside the public folder, we will need to add a file called firebase-messaging-sw.js. This file needs to be spelt correctly to work. Inside we will call import scripts with Firebase g static URL. Initialize app with our project credentials. Then call Firebase messaging. Run the application again, we can see the user's token value is updated. On the server side we need to set server message on create function, called private message. Set the const equal to the snap object values. Create an object that will contain the notification object and insert the data values from the snap object. We need get the token value from the user we are messaging. We can have this ever query the user's directory for it. Call admin.database with a ref set to users /UID from the snap object. Use once and value. Finish off with .then and snapshot for the promise variable. Check if snapshot exists and if it's not an empty string. If so we will call a function called send notification passing the user's token value. Create send notification function and use admin.messaging. Then send to device, which takes the token and payload. We will use .then and .catch. We can use function.logger.log, this will create data inside of your Google Cloud Platform Cloud Functions logs. Then in both statements call a function called remove entry. Create remove entry function and have it remove the object that triggered this cloud function. Set remove entry function call to the else statement in the user's query promise callback. Then deploy Firebase only functions. If we run our application we can send the user a message which then sets the server message. Server queries user's token then sends the notification, finally deletes the trigger object. We are now ready to deploy our application. Run npm run build via the terminal. This will build a production-ready version of our application and set it inside a build folder. Then enter Firebase init. Select real-time database to import new security rules and hosting. Allow to overwrite security rules. Use build as your public directory. This will tell Firebase to host your built application inside the build folder. I chose not to build as single-page app and not to build with GitHub. Do not let it overwrite build/index.html. Now we can finally deploy to hosting by running Firebase deploy only hosting. Your project is completely up and running in the wild for all to utilize and enjoy. We can get our application URL inside of the Firebase console/hosting. Let's update our app and then deploy the update to hosting. Copy the link to your web app. Then inside the src folder app.js. Go to the messenger function at the bottom of send message. In the notification payload we have a value called target set as empty string. Replace this with your web app URL. Now run npm run build to rebuild the application for deployment. Then run Firebase deploy only hosting. This is the final version of the application and the end of the tutorial. This has been front to back full stack with Foxcore Dev co-written by Kira Posey. Thank you.